All right. So that's the deal with 15. So 16 is a little, I don't know, contrived, I guess, for lack of a better term. So what happens in 16 is Magnus Ver Magnusson, who, if you care, is a real dude. So here he is. Here's Magnus Ver Magnusson. So he's going to take the kid and he's going to push him up to the top of the slide. And then the kid goes flying off and hits the ground down over here. Okay? So 16 is important because there are two non-conservative forces. Okay? There's gravity and there's... Oh, how did this all get here? That's weird. Two non-conservative forces. There's Magnus Ver Magnusson and friction. But exactly what I was going to say. We just found our force of friction, right? It's this. Okay, and that doesn't change at all in the next problem, right? Because it's still the same kid on the same slide, right? Okay, so here's what we know for 16. So we know that the kid starts at rest at the bottom of the slide. So at the bottom, the height is 0.4 and the velocity is 0. So that means that the GPE is 235.2, the KE is 0, which means the total energy is 235.2 joules. Cool? Then he gets pushed up to the top. When he gets to the top, now the height is 2.5, which means that the GPE is 1470. Question A wants to know what's the velocity at the top. So we got to find the kinetic energy at the top. But I can't find that kinetic energy without the velocity, so I'm stuck. So, question or solution, Weston?
Both?
Sure. All right, what do you got?
So, if he lost that friction, would you add friction, like the force of friction to the top point?
I don't know that I would think about it that way.
Okay.
I would think about it as, because the friction doesn't occur at just one point. Right? The friction is what happens as he goes from here to here, right? All right, so let's see if we can figure out what's going on. So once you get stuck, your question should be, what do I know about my total energy? So is the total energy at the top the same as it was at the bottom? No, because there are non-conservative forces doing work, right? So let's identify those non-conservative forces. So as he goes up the slide, yikes. As he goes up the slide, there are two forces. There's the force from Magnus Ver Magnusson, and there's the force of friction. No, that's not right. What was the force of friction again? I just found it.
0.2. Oh, never mind.
What is it? 256.2? Thank you, whoever mumbled that. All right. So how do I deal with this? So we've got two non-conservative forces, so there's two ways we can deal with it. Thoughts?
Convert it into joules.
Convert it into joules. How?
Well, his work equals 700 times he's pushing the whole 4.2 meters.
There you go. So yeah, so we got to use work equals force times distance. So there's two ways to do it. You can find the work that Magnus does by doing force times distance. Find the work friction does by doing force times distance and then adding them. Or
would you add the negative number?
I would just add that, yes, you'd be adding a negative. That's correct.
So you'd be subtracting.
Yes, correct. Yeah, so it would, yeah, right. So, but what I think is actually easier is to do this. Let's find our total non-conservative forces. So 700 minus 256 gives you 443.8 newtons, I think. Is that right? So that's sort of my net non-conservative force times the displacement, which is 4.2. So that'll give you your change in total energy. I think it turns out to be 1870, if I remember right. Why do I remember these numbers? I don't know. Oh, I was wrong, so I'm glad I checked. 1864. Cool. So that's how much energy we gained because it's positive, as a result of our non-conservative forces. So if the total energy at the bottom is 235, and I gained 1864, then I gotta be able to just add, right? Plus 1864, that'll give me this. So it gives you 2099 joules, and now you can find your kinetic energy and your velocity.
Okay, so like when I said like you added, I wasn't completely wrong. I just brought it
Right.
up. I don't.
But I want to make sure you understand that
No, I understood it was a correct, but like if you like split down, you would have to lose that much to get the total energy at the bottom. So you could just think about adding to the top.
Gotcha.
Yeah.
So you take it. So you have a total energy at the bottom. So you just add it to whatever's, like, you don't add it to the side where you have a variable.
I guess maybe the safe way for you to think about it, Weston, because sometimes you get yourself a little bit tangled, is it's just this. God, this board is such a mess today. So look, we just found the work of non-conservative forces, right? It was, what did I say, 1863 or 1864?
Yeah.
Equals TE final minus TE initial. And solve for TE final.
Okay, so then you add that,
And that gives you the 2099.
and then like the GT plus X equals that, and X is
All right, you guys, I'm around after school, I'm around before school. That did not feel like the best review.